Okay, so we're on 3C.5 polynomial functions. For 3C.5, you're going to have three parts to this. So let's dive in. So we're going to start with part one, degree and roots. And again, this is 3C.5, and for 3C.5, we're doing non-calculator. So degrees and roots. So when you have the degree and roots, we've been learning about how to identify it from an equation and how to identify it from looking at a graph. The degree, as we know so far, is the highest exponent in the polynomial, okay? If it's written not in standard form, you may have to distribute to find it. It indicates the maximum number of roots that we could have. So the maximum number of roots. And you're like, what's a root? Roots are the values of where polynomial equals 0. So where our polynomial equals 0 is called our root. Essentially, this is our x-intercept. We write that correctly. So this will be our x-intercept. Okay? You may have to factor or use the quadratic formula to find your roots. So remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, okay? So you may have to use that. The other thing I want to point out to you is that when we are talking about distribute, the reason why we say distribute is because you want it written in standard form, or in almost standard form, because honestly you don't have to go all the way through, but in standard form, that's where we would have our ax to the n plus our bx to the n minus 1 plus our cx to the n minus 2 plus dot, 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 dot. So n are integers. Remember, n is an integer, and we are decreasing in power. So let's look at this example. So we want to determine the degree and roots of this polynomial. So to determine the degree and the roots of this polynomial is actually fairly easy because this is in factored form. Since it's already in factored form, the first thing we're going to look for is its roots. To find the roots, you're going to set each factor equal to 0. So we set each factor equal to 0. So we're going to set x minus 2 equal to 0, and we're going to set x plus 3 equal to 0. So our roots, we have a root at x equal 2, and we have a root at x equals negative 3, because these are the values that would make these true statements. So therefore, in terms of writing it in terms of an x-intercept, it would be at 2, 0, and this would be at negative 3, 0. So this is where the graph would cross. Okay? Now, next, moving on, we are going to now find our degree. So to find the degree, it said that we have to distribute. Well, we don't have to fully distribute, we just have to partially distribute. You could fully distribute, which I'm going to model for you, but I'm going to highlight why you could partially. So if we were to fully distribute, we get x times x, which is x squared. We get x times 3, which is 3x. We get negative 2 times x, and we get negative 6. So we get x squared plus x minus 6, right? And so from here, we know that this is a second degree polynomial. Okay, so it's a second degree polynomial. But after you do this, you can realize that it only really matters is that you multiply your leading term in each factor. So we multiply our leading term in each factor, which would be x and x, and we still end up with x squared. And because your degree is based off of your highest power, then that's all we would need to do was to distribute the leading term. All right, so let's try another. All right, so example number 2, we have x times x minus 4 squared. Remember that square? This is really saying x times x minus 4 times x minus 4, okay? So there are 3 factors. It's just that we condensed it down to look like only 2. So to find our root, we're going to take each factor and set equal to 0. So our first one is going to be x equals 0, which is pretty straightforward. So x equals 0, that's a root, and our x-intercept is 0, 0. Next, we're going to do x minus 4, and we only have to do x minus 4 once. Even though it's repeated, we only do it once. So x minus 4 equals 0 means that x has to equal 4. So we have a root at 4, and therefore we have an x-intercept at 4, 0. Okay? Next, we're going to find our degree. So remember we talked about for the degree, you want to take the leading term in each factor and multiply them together. So our leading term in each factor, we have x, x, and x. Those are our leading terms. So we have x times x times x, which equals x to the third. So our degree is a third degree. All right. On to our third example. So for our third example, we have f of x equals negative x minus 2 to the third power, which means that we have negative x minus 2 times x minus 2 times x minus 2. Okay, further in this lesson, we're going to learn what that 3 means and how does it affect how the graph looks. But right now, we're just understanding that this is our factor. So first off, to find our root, because it's the same factor over and over, we only are using x minus 2 equals 0 once. That means that x equals 2 and that our x-intercept is at 2, 0. Okay, for our degree, we're going to look at our leading term, and our leading terms are x, x, and x. So therefore, the degree can be found by taking x times x times x, which equals x to the third. So this is a third degree polynomial. Okay, so we're going to pause here, and you're going to do number 4, example number 4, as your as your you do, and then we're going to check. Okay, let's see how you did on example number 4. So example number 4, notice that it says x squared, x minus 4 squared, right? So if you were to expand this out completely, which I'm just going to do just so you can understand, remember the square means that you have x times x, and you have x minus 4 times x minus 4, okay? So the square means that you have double of it all the factors. So we're going to first find our roots. So our root is x equals 0. I'm only using one of them. So we have an x-intercept at 0, 0. Next one is x minus 4 equals 0, which means that x equals 4, which means that our x-intercept is 4, 0. Okay, so we have a root at 0. That means our x-intercept is 0, 0. We have a root at 4. We have a root at 4, which means that our x-intercept is 4, 0. All right, so now we're going to go on to our degree. Again, your degree is taking your powers, your highest, your leading term, highest power, all these things. Now, if we do it from this problem, in this case, you can kind of look at it here. You have x squared, and then this square is going to make this x squared as well, right? So ultimately, you're going to have x squared and x squared. You can also just come over here and look at in expanded form, you have x, 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 and x. So when I'm looking at the degree, my leading terms that would all be multiplied together would be x times x times x times x, which would lead to x to the 4. So this would be a 4th degree polynomial. Okay, so that is part 1. Part 1, again, as you can see, we used no calculator. It was all just from us analyzing the factors. All right,